Alright, so this is part 2 on characteristics of functions. So in part 1, remember we did the domain and range, and for the domain we learned that it extended without n to the left and it extended without n to the right. So using interval notation, we use parentheses because it didn't end. And for the range, we use a bracket because the graph did not go any lower than -4, but it goes up to the sky, positive infinity. So now we need to learn about the extrema. And when you think of the word extrema, what is the first thing that comes to mind? I would think extreme would come to mind. So if something's extreme, then that means that it's going to be but a little bit different from average. So we're not looking at a point on a graph that's going to be regular. Okay, so if I say the maximum, then the maximum means this needs to be the highest point on the graph. Normally when you have a maximum, your graph will look like a hill. So in order for it to be the highest point on the graph, all the other points have to be under this point. So this is normally what it looks like when it is a maximum. It's the top point on the graph. And you have to give the x and the y value for the maximum. So your answer looks like a point. Okay? You have to have an x value and you have to have a y value. So please make sure that you copy this into the box on your page so that you have this to look back on and guide you through your classwork and your homework. Maximum is the highest point on the graph, and it needs to be written in a point like this with an x and a y value. So now that we have maximum written down, then of course we need to know what is the minimum. And the minimum will also be a point. This is going to be the lowest point on the graph. So normally when you have a minimum, that means all the other points are above this point, and it is the lowest point on the graph. So we normally have something that looks like this. You normally have this with a parabola shape, or you can have local mins and max also, but those will be in algebra 2. So this is how it's going to look for us when we have a maximum or a minimum, or you could have something that looks like this. I'm sorry, that would be the wrong example. So let's see. Alright, so maximum, I can have a point up here, and then for minimum, I can have a point down here. So it can also look like this, where this is the highest point on the graph and everything else is below it. Or for minimum, this is the lowest point on the graph and everything else is above it. You cannot have a max or a min if your line extends forever, because you don't have a lowest point or a highest point. Okay? So let's look at our graph and let's see if we have a max or a min. So let me clear this up. Alright, looking at the same graph we were looking at on the front page, I'm looking for a maximum point. So remember, in order to have a maximum, it kind of needs to look like a hill, and we don't have that in this picture. So for next to maximum, I'm going to write none, because we can't say negative infinity, positive infinity, because that is not a point. Negative infinity does not exist. It is a number that is what we use when something continues without end. Okay, so I can't write an x and a y value for this graph where the maximum point would occur. Okay, so that is no maximum. Minimum, we definitely have. There is a lowest point to this graph, and I can identify that point right here. So since I can obviously see this is the lowest point on the graph, there are no parts of the blue line that extend below this point, I now need to give the x and the y value. So remember, you go side to side first, so I need the x value, which is -1, and then the y value, the x value, which is +1, and the y value, which is -4. So we'll write that together as our minimum point. So So the minimum occurred at +1, -4. So notice that in order to have a max or a min, there has to be an obvious lowest or highest point on the graph. And if one does not exist, your answer is simply none. Okay? So now we move to x and y intercepts. I know you're familiar with the y-intercept. So in your box, I need you to go ahead and write down these definitions for your x and your y-intercept. And Ms. Hall can pause the video here to allow you time. Well, she can pause the video in a little bit as soon as I move this box so that you can have the time to copy your definitions. So inside the box that looks like this on your paper, I need you to fill in these vocabulary. So the x-intercept is a point that looks like this. Notice that I put the value x first. This is going to be a number when you actually write your x-intercept. So it will look something like this: 5, 0. So x will get the number since we're talking about an x-intercept. Okay, you have to pay attention to where the number is. On your EOCT and on your CDA, they will give you several points that have the number 5. One of your points will have the number 5 first, and one will have the number 5 second. So you have to pay attention to where they put it. If you're identifying the x-intercept, x should get the number. That's the easiest way to remember it. This is the point where the graph touches the x-axis, because we're talking about x-intercept. An intercept means to cross. So if we're talking about y-intercept, then y gets the number. So it would look like this if it was a y-intercept. So 0, 4, because y gets the number, it is a y-intercept. And this is the point where the graph touches the y-axis. Notice with the x and the y-intercepts, you will always have a 0 as one of your numbers. That is the easiest way to identify your x and your y-intercepts. It's the y-intercept if y gets the number. It's the x-intercept if x gets the number. Okay? So now that we have that copied down with our definitions, okay, let's go up here to our graph and let's identify the point where it crosses the x-axis and the point where it crosses the y-axis. Okay, I need to clean this one up too. Alright, so let's use purple to identify. The x-intercept is written first, so remember this is your x-axis, and right here, this goes all the way across here. And in this example, I can clearly identify 2 places where the blue line hits the x-axis, which I just drew in purple. This is one of those points, and this is the other point, which means I have 2 separate points that I have to write as my x-intercept. So what is the x value at this point? -1. So when I write this point, x gets the number, which is -1. And then the other one will be a 0. Alright, so x gets the number, -1, and the other one will be a 0. So now I go back up to the top. What is the point that represents the other one? What is the number that represents this point? The number 3. Notice the x value is 3. So when I write this point, 3 has to be first. So notice we had 2 different places where it intercepted the x-axis, so we wrote both of those points. That is where the blue line touches the x-axis. Okay? Now the y-axis goes straight up and down, and this is the one you're most familiar with because we did this one with y equals mx plus b. So the point where it hits the y-axis, and we're still talking about the blue line, is right here at -3. So since this is a y value, when we write our point, does the y number go first or second? It should go second, okay, because when we write our points, we have the x value first and the y is second. and this value right here is negative 3. So what in the world am I going to put for my first value? 0. Because it is the y-intercept and it has to have a 0 in it. So this is the x value, this is the y value. Since it is a y-intercept, the negative 3 goes in for the y value. These were x-intercepts, so notice x got the value here and y was 0. So remember, easy way to tell x and y intercepts: if it's an x-intercept, x gets the number. Where does it hit the x-axis? If it's a y-intercept, y gets the number. Where does it hit the y-axis? Alright, so the last thing that we're doing today for characteristics of functions is called the end behavior. End behavior. And its name kind of gives you a hint as to what you're doing. End behavior means what is it doing at the ends of the graph. Look on the left side of the graph, what is it doing? Look on the right side of the graph, what is it doing? So in this box that you have next to end behavior, I need you to pause the video so that you can go ahead and fill in your box with the vocabulary. End behavior describes what happens to the y values on the graph as x approaches positive infinity, so as we look at the right side of the graph, and as x approaches negative infinity, as we look at the left side of the graph. Alright, so now that you have your vocabulary in, let's figure out what this terminology means. This little box down here is how they're going to set up your answer. So they're going to say as x approaches positive infinity. Well, I know for some of you that's kind of hard to understand. So all you want to do is whenever they ask you about the positive side of x, look at the right side of the graph, because the right side of x, the positive side of x is on the right side of the number line. When they ask you about the negative infinity incurs that we are looking at the left side because that's where the negative numbers are. So if they say positive infinity, that's where the positives are. When they say negative, look at where the negative numbers are for x. Now the value that you're giving them is what's happening to the y. What is the y value at the right side of the graph? What's the y value at the left side of the graph? Okay, so let's look at our graph. Okay, so this would be on the left side of the graph, on the right side. Alright, so I'm looking at the right side of the graph. Let me clear up my little images that I have here. Okay, excuse that little square that's up there in the corner. Alright, so what I like to do when I describe what's happening on the left side of the graph is I like to go ahead and trace it, okay? So you always start at 0. The graph starts at 0 here. What is happening to the graph as we move on the right side of the graph? What's happening? The graph is going up, correct? It is going up to the sky. It is never going to stop. It is going to what? Positive infinity or negative infinity? Positive infinity is the correct answer. So when I go down here on the line, and we'll go back to purple. So when I look at the right side of the graph is going to positive infinity. Okay, I don't have to put the plus sign. If you want to put the plus sign, that's fine. It's not wrong if you don't put the plus sign. Alright, now we're going to look at the left side of the graph. So I'll go back up here and I'm going to change my color because this time we're looking at the left side of the graph. Okay, so left side, we start at 0. What's happening to the graph as we move to the left? Well, it is moving to the positive infinity. Everything's going up when we look at the left side, when we look at the right side. And notice that I always start at 0 and I trace the graph from 0. Where is it going? Up. So up means positive infinity because we don't have an end point. So I go back down here, and that means it is going to positive infinity on this side of the graph also. And I will get better with this pen in this little wireless slate, the more I use it. So excuse me. Alright, so let's recap. Domain, x values. Range, y values. Alright. Extrema, the highest point. Maximum. And it has to look like a hill to have a maximum point. Or have a point that's at the top and the line going down. That both of those will give you highest points or maximums. And minimum is the lowest point. So we can have a line that starts at the bottom and goes up, or we can have a parabola that has an obvious lowest point. Okay? X and y intercepts, this is where it hits the x-axis. This is where it hits the y-axis. And both of these points have to have zeros in them. So remember the easy way. If it's the x-intercept, give x the number. If it's the y-intercept, give y the number. That's the easy way to identify x and y intercepts. In behavior, trace your graph from 0 to the right. Where's the graph going? Positive infinity. Trace your graph from 0 to the left for negative infinity. Where's the graph going? Up, positive infinity. Okay, so positive infinity meant that it was going up and it did not stop. If it was going down and it did not stop, then we would change these to negative infinity. Okay, and it doesn't have to be negative or positive infinity. It could actually be a number. So that is part 2 of the lesson on characteristics of functions. I hope that you were paying attention. You probably have at least 10 problems on your CDA. They're going to go over characteristics of functions. Domain, range, x-intercepts, y-intercepts, maximum, minimum, and in behavior. Thank you so much. Please make sure that you're on your best behavior from Ms. Hall. Remember, the class that has the best average on tests and quizzes and gets the best note for behavior gets a pizza party from Ms. Anderson when I come back. Thank you.